Okay, I want to take a look at this handout that I've posted online, Intro to Regression using calculators. And I want to do number one with you, and then your only homework is to repeat the process, but with number two that's on the page. So regression means the way that we're going to talk about it. It means that I give you some real life data, and you can create a graph with that data. And so, maybe your data looks like this when you graph it out. And so you might guess that if you get something like that, a quadratic equation is a pretty good model for it. And so the calculator can actually get your data and then analyze it and give you a good model for it. So I'm going to show you how to do that. I don't know if you guys actually did it last year or not, but it's probably good practice to see it again anyway. So this problem here, number one, has to do with with how to estimate ages of trees. And you might know that one way to estimate, to tell how old a tree is to chop it, take a slice of the trunk and just count the rings. But you can probably imagine the problem with that is you kill the tree in order to figure out how old it is. So that's not really the best way of figuring out how old the tree is. So instead they come up with estimations, and it's based on how wide the tree is. And then you can kind of estimate how many rings it might have based on that. And so they've done enough data collection for oak trees to come up with this chart here. So what we need to do is input the chart. So if you go to the stat button on your calculator, you can edit these lists of data. And right now I don't have any lists in here. If you're missing L1, I'm going to get rid of it for a second. So if you're missing L1, you can go second, insert, and then just, it asks for a name. I'm going to use L1 down here and hit enter. And so now it's there. If you have data here already, just hit delete over and over and over to clear it all out. So the stuff that you can measure is the diameter. So those are going to be our x's. So I'm going to say x equals the diameter. And I'm going to say that y equals the age. So I'm going to use L1 for my diameters. So 2.5, 4.0. Remember, I got here by hitting stat edit. 6.0, 8.0, 9.0, 9.5, 12.5, 15.5. And then in L2, in L2, I'm going to enter the years, 15, 24. And they have to match up the correct way because they're going to correspond to each other. 32, 56, 49, 76, 90, 89. Okay, there we go. If you don't have the same number here, then you missed one somewhere. So then none of this will work. All right. So the calculator has the data in it. So I'm going to second quit. Right, I'm back on the main screen. Well, I want to see that data. So right now, your calculators are all probably set to the standard window. And that doesn't show anything because none of the data is in the -10 to 10 range. So what we do instead, the calculator, once you have the stats entered in, I can turn on my stats. So I'm going to go to stat plot up here, second stat plot. And you have all these different options for plotting. I'm going to go to option 1. I'm going to turn it on. And then this is, do you want the data points connected? Do you want a bar chart? Stuff like that. I'm going to keep it on that option right there. I don't want to connect the data points. I just want to see them. My X's were L1, so that's all good. My Y's were L2. If for some reason it's not showing up as L2, it's something else, or not showing up as L1, all the L's are down here. And so we stored the Y's as L2. This just says, how do you want the data points to show up? Do you want little squares? Do you want little crosses? I never use the dots because you can barely see them as they are. So now if I go to graph, they're not showing up. I need them to show up though. But luckily the calculator can analyze all the data for me. So when I zoom, I'm going to go to zoom stat. And there they are. If I hit trace, I can actually see my data points, 4, 24, 6, 32. Okay, so I've got that much. What you could do at this point is pause, draw a sketch of the thing, and then come back to the video. But really the goal is to come up with the model for it. And in this case, I'm going to use a linear model. I want to get a line equation for that. So in order to get the regression models, the regression tools that actually get you the equation, you go back to stat. And instead of editing your stats, you're going to calculate stuff with them. So I'm going to go over to calculate. The first three you don't have to worry about for this class. Fourth one is linear regression. So that'll give me its best guess as to a line that fits it. There's quadratic regression. So if it looked like a parabola, you'd probably use quadratic. That's cubic. Quartic is x to the fourth stuff. This is just the same thing. It's linear regression, but instead of giving you an ax plus b, it gives you an a plus bx. So that's not really that different. That's natural logarithm, which we'll get to later. Exponential functions look like, you know, the growth or the decay stuff. This one, though, there's some other ones too, power, logistic. But the one that we're going to use, it looked kind of straight, so I'm going to use this linear regression tool right here. Okay, and now it asks you, what do you want to do for your x list and for your y list? Well, we stored it as L1 and L2 right over here. This one was L2. So it's already set up, but otherwise you have to type them in. Don't worry about this thing. That doesn't do anything for us. This is going to be useful because what the calculator is going to do is it's going to spit out what it thinks A and B are. But if I want to store that so I can graph it later, I'm going to tell it to store it as Y1. And the shortcut for that is this F4 button. So I'm going to go alpha, F4, and tell it to store it as Y1. You can pick any of the Y's that you want it to store it as, but I'm going to pick Y1. And then I'm going to say calculate. So there's what I get, and it spits out my answer. My answer here is y equals, it's about 6.451x plus, or minus actually, 0.152, let's say. Now I actually have this stored already in my calculator. If I go to y equals, there it is, right? It's all in there and it's stored all the decimal points on there, right? Ton of it. So I don't have to worry about actually typing it in anymore. Notice this thing up at the top is on, right? Plot 1 is on. If I turn it off, now all it's going to graph is the line. If I turn it on, it'll keep the data points there. So if I hit graph, there are my data points. There's the line. One suggestion, before you go on to do another graphing problem, turn off the stat plot because it creates a lot of issues for people when they're doing problems that don't require stats. Sometimes it won't graph at all and you won't know why, and it's because you have a plot that's turned on. Okay, so anyway, there's our graph. You can sketch that. We have the equation for it. I'm going to go back to the main window now. Okay, so you can copy down the graph and everything. And then it says use the model to estimate the age of an oak tree whose diameter is 18 inches. So that means that x is going to be 18. And I want to estimate the age, which is going to be whatever y value I get. So you can type that in. You know, you can write y equals 6.451 times 18 minus 0.152 and figure out what that is. But you're going to get an estimate. You're going to get a rounded number right here because we rounded off these decimals. The calculator, however, has it stored in to like 9 decimal places, which is pretty accurate. So if you actually, it's stored as y1, and so you can tell your calculator, let's look at y1 and plug in 18 for x. That's the way the calculator would interpret this. So if I go to alpha F4 on the main screen and say y1, and then say, okay, I want you to plug in 18 next to it, into it. And then I hit enter, there it is. This is going to be 115.966. This is the same thing, 115.966. My units are years. Okay. This notation, if it's confusing you, think of it like f of x, right? If f of x equaled x plus 2 squared, and you wanted f of 4, well, then it's just plugging in the 4 in for the x's. That's the same thing that it's doing here. y1 equals this thing. So if I do y1 of 18, it's plugging in 18 for x. That's all that that means. So a couple calculator tricks. What I want you to do now, go back to your stat plot, make sure you turn it off just in case you do some non-graphing problems. So you turn it off, right? So notice now it's off. And if I were to graph now, it's only going to show the line. Okay? So what I want you to do is to go ahead and try number 2 that's on that page and bring that to class tomorrow. You can either print out the page itself, or you can just do it on the side on a separate sheet of paper. Okay, if you get stuck, remember to come back, watch the video, find the buttons that you need. Remember L1, L2, stat, edit, right? The edit to input the lists, the calc to actually get the regression line. Okay, good luck with that. I'll see you tomorrow. If I can figure out how to shut this off. Anyway. Nope, can't figure it out.